4.3 Trigonometric functions on the unit circle. Let theta be any angle in standard position and point P, xy, be a point on the terminal side of theta. Let r represent the non-zero distance from P to the origin. That is, let r not equal 0. Then the trigonometric functions of theta are as follows. So what they're saying is if we have this angle here, we're going to find the sine, cosine, and tangent, and the other three for this angle. Well, to find the trigonometric functions for this angle right here that's clearly past 180, we're going to use what's called the reference angle. And we're just going to use the angle that is from the x-axis. So in other words, we're going to use this angle right here, this one, but we will know that the x is negative and the y is negative as well. So we can use this angle right here to find the trigonometric functions of the big angle. They're going to be the same with the exceptions I mentioned. Sine is y over r. In other words, if this is the angle right here, then we have opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent would be opposite, or the y value, over the adjacent, which is the x value. Let negative 4,3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trigonometric functions of theta. So we're going to plot negative 4,3. 1, 2, 3, 4. 1, 2, 3. There's negative 4,3. And we're going to find the trig values of that angle right there. To find the trig values of this angle that's past 90, we're going to use the acute angle right here. And we will know that the x is negative and the y is positive. So this value right here is negative 4. This value is 3. This is a 3, 4, 5 right triangle. And now we can get all of the trig values. Sine is opposite over hypotenuse, so that's 3/5. Cosine is going to be negative 4/5. That's the adjacent over hypotenuse. And tangent is going to be negative 3/4. Cosecant, reciprocal of sine. Secant's reciprocal of cosine. And cotangent is the reciprocal of tangent. Let 3, negative 6 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trigonometric functions of theta. So we're going to plot the point 3, negative 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. I didn't plan that out real well, did I? So here is the angle right here. That's that angle. We're going to use the reference angle. So we're going to use this angle right here. And we always go to the x-axis. So this is 3, this is negative 6. Well, 36 plus 9, square root, that's square root of 45. That is 3 square root of 5. So using Pythagorean theorem, the hypotenuse, or the radius, is 3 square root of 5. So now sine is opposite over hypotenuse. We have negative 6 over 3 square root of 5, which is negative 2 over square root of 5, which is negative 2 square root of 5 over 5. Cosine is adjacent over hypotenuse. That's going to be 3 over 3 square root of 5, which is square root of 5 over 5 after we cancel out the 3's. Tangent is opposite over adjacent, which is going to be negative 2. So cosecant is negative square root of 5 over 2. I'll use that one to turn upside down. This one, secant, is going to be square root of 5. I'll use 1 over square root of 5, turn that upside down. And then cotangent is negative 1/2. Common quadrantal angles. When we start at 0, we could get another angle by opening up the two rays to this distance. But if I went back down to 0, notice how the opposite side is working its way down towards 0, and the adjacent side, if this is the angle right here, is working its way to 1. So we have 4 corners of the circle. Now notice as we go up to 90 degrees, or pi over 2, the adjacent side is getting smaller, and the opposite side is now getting longer. And the opposite side is working its way up to 1, and the adjacent side now is working its way towards 0. So right here we have R0. Up here we have 0R. Back here we have negative R0. And here we have 0, negative R. And then when we go all the way around the circle, we get back to R0. So we're going to find the following. The sine of pi. Well, the sine of pi, which is right there, is going to be, if this is the triangle, not rectangle, triangle right here, sine is opposite over hypotenuse, which would be 0 over 1. So we have 0 over 1, which is 0. The cosine of pi would be adjacent over hypotenuse, which would be 1 over 1. Because remember, this side is going to work its way to 1, and the hypotenuse is 1. So the cosine of pi, I guess I should say negative 1. Negative 1. The sine of 3 pi over 2. Let's look at this one. Sine of 3 pi over 2. Here's 3 pi over 2 right here. And notice how this would be the angle right here, or the triangle. This would be the triangle. And the opposite side is working its way to 1, and the adjacent side is working its way to 0. So the sine of 3 pi over 2 would be opposite over hypotenuse, which would be negative 1. The cosine of 3 pi over 2 would be 0, because we'd have adjacent over hypotenuse, which would be 0 over 1. The tangent of pi. Well, pi radians is over here, and let's take a peek at almost 180, or almost pi. Tangent of pi is opposite over adjacent, which would be 0 over negative 1. So 0 over negative 1, that's going to be 0. The tangent of 3 pi over 2. So there's 3 pi over 2. Here's one of the triangles. And tangent is opposite over adjacent, which would be negative 1 over 0. So that's negative 1 over 0, which is undefined. Find the exact values of tangent of 450 degrees. If not defined, write undefined. So we need 450 degrees. Well, if we go all the way around, that's 360, and another 90 is now 450. So really what we're looking at is the tangent of 450 degrees. Let's take a look at one of the triangles as we get close to 90 degrees. That's opposite over tangent is opposite over adjacent. So once we get up to 90, this opposite side will be 1 and the adjacent side will be 0. So we're looking at 1 over 0, which is undefined. So the answer is letter D. Find the exact value of cotangent of 7 pi over 2. If not defined, write undefined. Cotangent of 7 pi over 2. So here's 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. So we're looking at the cotangent of really 3 pi over 2 is the exact same thing. Let's look at one of the triangles that's getting close. So the adjacent's getting really close to 0, and this opposite side is working its way to being 1. So cotangent is adjacent over opposite, which is going to be 0 over negative 1, which is 0. Find the exact value of secant of 3 pi over 2. So we have 3 pi over 2 is right here. Let's look at a triangle that's getting close to an angle that's getting close to 3 pi over 2. And secant is reciprocal of cosine. So if we know the cosine of 3 pi over 2, then we can just take the reciprocal. Now cosine is adjacent over hypotenuse, so we have 0 over negative 1. So 0 over negative 1, that would be 0. So we're trying to find the secant. So now secant of 3 pi over 2 is negative 1 over 0, which is undefined. Reference angle rules. If theta is an angle in standard position, its reference angle theta prime is the acute angle formed by the terminal side of theta in the x-axis. The reference angle theta prime for any angle theta 0 to 360 or 0 to 2 pi is defined as follows. If we're in first quadrant, then theta prime is the same as theta. So in other words, if our angle was 35 degrees, then the reference angle is 35 degrees. If our angle was, let's say, 150, then our reference angle would be the distance or the amount of degrees or radians it would take to get to the x-axis. So to get to the x-axis, this case would be 30 degrees. So the reference angle is 30. Now, if we go past the negative x-axis, the reference angle is, well, how far past did we go? Or in other words, how far away is the angle to the x-axis? And the same rule applied over here. The angle is 35 degrees from the x-axis. And same thing over here. How far would this angle be? How far away from the x-axis would this angle be? That's the reference angle. Find each reference angle, 2 pi over 3. So 2 pi over 3, here's 1/3, here's 2/3. 2 pi over 3 is 1/3 away from the x-axis. So this would be pi over 3. 4 pi over 7. So we'd have to cut pi into 1, 2, 3, 4, 5, 6, and there's 7 sevenths. So we have 1, 2, 3, 4. That's just 1/7 past that pi over 2. So it'd take 1, 2, 3 sevenths to get to the closest x-axis. So the reference angle is 3 pi over 7. How about pi over 3? Well, that is in the first quadrant. So the reference angle is pi over 3. 8 pi over 5. So we're going to cut pi into 5 pieces. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 pieces. We're not counting this piece or that line right there. We have 8 pi over 5. So I'm actually past pi. So we have here, there, another one. Here's another fifth. Here's another fifth. So that should be 10 pieces altogether. 1, 2, 3, 4, 5, 6, 7, 8 would be right here. So we're 2/5 away from the closest x-axis. So 2 pi over 5. I need 5 pi over 4. Let's get a little room here. 5 pi over 4. So we have 1, 2, 3, 4, 5. That is actually 1/4, 1 pi over 4 from the nearest x-axis. So its reference angle is pi over 4. How about negative 7 pi over 12? Well, this would be, I need 1, 2, 3, 4, 5, 6. It would be halfway. And then one more would be negative 7 pi over 12. So to get to the nearest x-axis, I would need to go 5 more. So 5 pi over 12 would be the reference angle for that one. 84 degrees. 84 degrees is still in the first quadrant, so the reference angle is 84 degrees. 138 is in the second quadrant, so we need to know how close this angle is to the nearest x-axis, and that would be 42 degrees away to get to that 180 degrees. 200 degrees. 200 degrees is 20 degrees past 180. So to get back to that nearest x-axis, you'd have to go 20 degrees. 285. That is a little past 270. As a matter of fact, it's 15 degrees. So that's going to be 15 degrees past 270. And to get to 90, so from here to here, this distance right here would be 90. So to get to 90, I'd have to go 75 more degrees. So 75 degrees is its reference angle. Negative 45. Negative 45, there's negative 45 degrees, and that would be 45 degrees away from the nearest x-axis. And then finally we have negative 320. So there's negative 320 is almost to 360. Now to get to all the way to 360, we'd have to go 40 degrees.